Here's our question this time. A gun fires a bullet almost straight up from the edge of a 100-foot cliff. If the bullet leaves the gun with a speed of 396 feet per second, its height at time t is given by h of t equals negative 16t squared plus 396t plus 100, measured from the ground below the cliff. Once again, the formula is given. H for height. Height equals negative 16t squared plus 396t plus 100. Let's make a couple of observations. I've drawn a quick sketch of the scenario. Here's a cliff 100 feet tall. Here's ground level down here. So at this point here, h equals 0. The bullet is being fired from a gun up here. Notice that at the time when t equals 0, the moment that the bullet is fired, that bullet is exactly 100 feet above the ground. So if I were to replace t with 0 here and here, I would get a height of negative 16 times 0 squared plus 396 times 0 plus 100. This is 0, and this is 0, and 0 plus 100 is 100. So at t equals 0, the moment the bullet is fired, the height of the bullet is 100, and that makes sense. Also notice that the bullet has a speed of 396 feet per second, and that speed is represented by this number here. Don't worry too much about where the pieces come from. I think this is an interesting exercise, but basically your formula is given. What's important is that you know how to use it. The last thing to notice before we start talking about the questions themselves is that the height is given by this formula, but that it's measured from the ground below the cliff. In other words, at time 0, we're at 100 because a height of 0 is down here. If I asked you, what's the height of the bullet after 10 seconds, it would be a positive number because we're measuring from the ground up. That's what this piece means. All right, now let's talk about the actual question here. When will the bullet land on the ground below the cliff? When is a question about time. So we're looking for t equals something. The t is the variable we're solving for, not h. As it happens, we know h. H, when the bullet lands on the ground, is 0. So replacing h with 0, I have this equation. It's up to you to figure out what the greatest common factor is, factor what's left over, and find the solutions. You should get t equals 2 different solutions. Should you have one answer or two? Read the question again. There's only one correct answer here. You'll come up with 2 solutions when you solve the equation. Which one of the 2 solutions should you accept as the answer to this question? In Part B, we're asked to make a table showing the bullet's height every 5 seconds, from the time it is fired, which is t equals 0, to the time it lands. We don't know what time it lands yet. You'll have to answer Part A first. But we can start our table every 5 seconds until we get to the time that we found in Part B. Filling in this table means taking each of these t values and plugging it in to this equation. We've already done 0 because I said if t equals 0, what's the height of the bullet at that point? And we determined that if we plugged in 0 here and here, we would get 0 plus 0 plus 100. So the height of the bullet after 0 seconds is 100 feet. And that does make sense, because that's where it starts. The next value I'm going to use is 5. Make a note, though, it's faster to substitute into the factored form. So while I could plug 5 in here and work out the answer, it's actually going to be easier for me to do that once I've factored this. Plugging in a value here and here and then multiplying the results is a lot faster and a lot easier than plugging values like 5 and 10 and so on into the expanded form. It's up to you, of course, but this hint here, or this note, is meant to save you time. That should be enough to get you going on this problem.